You're listening to Everyday Engineering, the City of Madison's engineering podcast where we talk about infrastructure. Complex topics explained simply, from the water that flows down your drain to the rain and snow that drains into the lakes. By way, the curbs and streets we design. City engineering touches your life in so many ways. Explained right now in Everyday Engineering. You've heard the buzzword, but what does it actually mean? Green infrastructure, rain gardens, permeable pavement, green roofs, you name it. It's infrastructure that works with the environment. And in our case here in Madison, a forward way of thinking of approaching stormwater and flood management. My name is Hannah Mohelnitzky, City of Madison Engineering Division Public Information Officer. Here to share why you should care about green infrastructure are engineers Jojo O'Brien and Phil Gaebler. Thank you both for being here. All three of us are masked because of COVID, of course, so you might hear us a little muffled, but we're going to make it work, aren't we?
Yeah, thanks for having us. We'll see how it sounds.
Yes. Yes, of course. So let's start basic. For anyone who does not know what this is, define green infrastructure and kind of share why generally our listeners should care that we're even trying this out.
Yeah, of course. So green infrastructure actually reduces and treats stormwater at its source. So that means where the rain falls from the sky, instead of moving it a really far way away or trying to get it to the lakes, we're actually going to try to treat it pretty close to where it touches the ground. So typically, stormwater, when it falls, it runs off of surfaces. So it can't soak into your driveway, it can't soak into your roof. It's going to flow into the street, that flows into the pipes. Those pipes take the water to the lake. If everything goes well, it might flood a couple houses on the way, depending on how much rain is falling and how big the pipes are. And that's a lot of water that moves through very quickly. So as I said, can cause flooding and then adds a bunch of nutrients to the lakes. So what green infrastructure can do, if you're treating it at its source, you're not bringing it to those lakes, you're not putting it into those pipes. And it can actually help decrease flooding. And it can also, the primary purpose of doing it is to reduce those nutrients that end up in the lake.
Sounds like a whole lot of great.
It is, and there's even more,
Yeah.
right? So if you look at what your normal lawn can provide as far as food goes for insects, which are then food for birds and other insects, it's almost nothing, right? Grass is not the best food. But if you put in a rain garden, which we'll talk about later, you can have a huge variety of native plants that help the water soak into the ground and end up being that food for all these insects and butterflies and pollinators and things that we want to have in our urban environment.
There's a lot of buzzwords like, if someone isn't familiar with green infrastructure or permeable pavement or rain gardens or, all the different types of green infrastructure. Let's go through some of that. What are they? If people hear them, what do they mean?
Yeah, so we can briefly go over a few. So a rain garden, I think, is the most common one. That's something where you're actually creating a depression where the water can pool. And then instead of the water just sitting there, by having the right soils there and then planting it with native plants, those native plant roots go really, 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 really deep down. And that helps the water move into the soil a lot quicker, so it infiltrates. So the water soaking into the ground is called infiltration. And those rain gardens help promote that infiltration a lot quicker. You can also just take your downspout, and if it's going right onto your driveway, you can direct it to your lawn. That's something that we would consider green infrastructure, kind of in a simple, very easy DIY way. Phil, do you want to go through a few more?
Yeah, so we also have permeable surfaces. So this is if you, your normal asphalt or concrete, no water can soak through that. By design, it's supposed to have water run off. This is that you have essentially holes in it that lets the water go through and soak into a rock crib underneath it and eventually into the ground.
That one is really neat, and we'll revisit it a little later too, but that one I feel like also is not as familiar, but people have a lot of interest in permeable pavement. I get a lot of media requests about it as well and interest from residents, but I've learned a lot about it. It's kind of cool.
Yeah, and we also have green roofs.
Also cool.
Which are very cool. When you look at the return on investment for a green roof, it's a little bit maybe outside the reach of a resident. Mm-hmm. But a lot of the urban cores, green roofs help to combat the heat island effect, and then also provide kind of an aesthetic place and some outdoor space for some of these larger, dense urban areas. So they're a fun one.
Yeah, and even at our engineering operations center on Emo Street, they have a green roof, and everyone says how much they like to go outside and eat their lunch there, and then they see all these different butterflies and insects and pollinators and such. So you can, it's a really good way to be able to see the impact of green infrastructure in a very urban area.
And it's like a garden on a roof, but with more heavy-duty support to catch the rainwater.
Exactly.
Yeah.
Yep. And they vary from 4 inches of soil to almost over 3 feet. I think on Chicago City Hall they have a really intensive one. Not open to the public. I got to take a tour once. It was cool.
Yeah.
A little nervous towards the edge because there's not a railing, but it's only 80 feet.
Okay, what else do we have? So we have we went through rain gardens, green roofs, anything else on here, permeable pavements, anything else you want to hit on for examples so people can know?
Yeah. So something that we have been doing on street reconstruction projects is putting rain gardens in terraces. And sometimes rain gardens don't quite fit in a terrace, or it doesn't make sense to direct the street runoff into the terrace. And the terrace is the area between the sidewalk and the street, that little grassy patch. So something that we're expanding those rain gardens to be is something that we would call a stormwater terrace. So if we're able to store stormwater in your terrace, boom, we call it a stormwater terrace. And you can go from something that's deeper and has those big native plants like a rain garden and there's a little cut in the curb so that the water from the street can enter it. And then we also have something that just takes the water that falls there and it doesn't let it flow off. So that's just a smaller depression in your terrace, and we call that a rain basin.
So many options.
Yes, we're trying to make sure that if people have certain things that would disqualify them from one type of green infrastructure, that we can still look at having some other types, even though they may not be infiltrating the most amount of water or taking water from other places. Just doing what we can in the areas that we have is really important.
And then one other thing, which is a pretty easy thing to do, is soil amendments. If you look at how new subdivisions are constructed now, essentially all the topsoil gets stripped off. You drive heavy equipment everywhere. You compact that soil, and when you compact the soil, you squish out all the air pockets. So there's not any room for the water to go. We're going to talk about this in a different podcast, but you can add compost back to that soil, and if you do it in the right way, you can really reduce the amount of runoff and help to let your grass grow much more healthily.
Wow. I think you look at all these options, and if I'm a resident and I'm listening to this, I'm thinking, okay, how much is this going to cost me? And obviously it varies. Some of them are more, again, like within the range for if you're like developing a bigger space or a building or that sort of thing. But there are other parts of these examples that might be a little more resident friendly from a cost perspective. So like, what are we talking here? How expensive is it to do any of these, or roughly, like, how does that work into it if we're listening and we're wondering, how much is this?
So when you look in the right of way, right, things are pretty expensive. We're talking pretty good multipliers compared to traditional concrete. If you look at permeable pavers or articulated concrete blocks or precast concrete, like you're maybe in the $25 per square foot for that system to be installed, and that's significantly higher than your normal street. If you look at the rain gardens there, it depends on the bids that we get and the contractor putting in the work, but we're maybe at, let's call it $3,500 for a rain garden, and our residents are paying somewhere between $100 and $400 depending on the year for those rain gardens. So they're getting a great deal. And that's a fully planted rain garden with a curb cut and a flume and engineered soil. If you then start to move out of the right-of-way, you're not competing for space as much. It's a little easier construction. And if you do the work yourself, you can get that cost down to under $100 for a rain garden that does a lot of good.
I think that as I'm listening, a rain garden might be the best first option if people are trying to explore green infrastructure on their own at their homes, or trying to, kind of engage with that idea and support that infrastructure. So rain garden, and also a plug, you can go to our website, cityofmadison.com/engineering, and we have a whole brochure on how to build a rain garden in under $100. So there is some options for you to do this on your private land also that's affordable. Let's talk about the green infrastructure pilot project for some of the residents in the Westmoreland neighborhood in Madison. Can you kind of explain what's going on there, why that neighborhood, and what are the sort of the things that we're doing to work with residents in that area?
Yeah, so this pilot project came about because the city is looking to try to incorporate green infrastructure citywide, but to understand the impact and how much you need to incorporate to impact the volume of water from a watershed. So now you're looking not just at one property, but at a whole series of blocks or a whole neighborhood that drains to one point. To try to see what that impact is, we have some scientists at the United States Geological Survey that were willing to go through a 5-year experiment with us. So we picked a watershed, and we picked the Westmoreland neighborhood because it's within the Wingro watershed study, which calls for more infiltration and more rain gardens to help water quality in Lake Wingro. And what we're doing is we're both trying to install green infrastructure in the right-of-way, where a city has the immediate jurisdiction to install green infrastructure as it fits and as we can pay for it within the stormwater utility fees. And then additionally, knowing that there's only so much space within the right-of-way, we're trying to incentivize folks to be able to install green infrastructure on their own property. So that I think we're going to get into a little bit later here, but part of that is an incentive program to try to see if we can pay people to do that, how many people are actually willing to install it, to see if cost is that barrier. And then we'll be analyzing that data where we're monitoring the water that flows through that system over the course of 5 years to see, as we add more and more green infrastructure, what does that actually look like for the water leaving the pipe and heading to the lake. Phil actually designed a lot of the green infrastructure for the street reconstruction project there, and that's kind of the big first step of this project.
Right, and I've had the question also, why this neighborhood, right?
Yes.
And Jojo talked about how it's part of the Wingro watershed plan to put in a lot of green infrastructure, but there's other portions of the city that would benefit from this as well. And one of the main drivers here was looking at the way that the storm sewer drains. In order to reduce the amount of monitoring equipment you'd have to put out, you want to have something that comes to 1 point or 2 points. And those are surprisingly hard to find in the city, in the right size and right area where we had enough space that we would get enough runoff and also have this everything drain through to 1 point. So that also factored into our selection of this neighborhood for the project.
And the other piece of that is that we needed a very similar size, similar makeup, so house size, width of streets, etc., that would all drain to a point nearby that we could use as a control. So we're not going to go out of our way to install a ton of green infrastructure in this paired basin so that you can actually compare the changes over time.
Okay. So also, we're already doing a reconstruction project there as well, which is a part of it also, which I understand. It also makes it a lot easier to kind of get in there and try some of these things. And if anyone's listening to this, yes, so this neighborhood, basically, we're working with residents to incorporate like permeable pavement options and basins and rain gardens and the terrace rain garden, like all of the things that we've been talking about so far. These residents are kind of getting a taste of it if they haven't already, and embracing it in the public right of way. Now, we're also rolling out and have rolled out a new incentive to get people to install green infrastructure in this pilot project, in the perimeter of that, for their private property. So there's a program for them to kind of get them, kind of like a carrot. Hopefully it will help get them to embrace it on their private property. So talk me through the incentivized program that way.
Yeah, so the way that this policy is written is that we are able, as the engineering department in the city of Madison, to reimburse residents for up to $1,000 for green infrastructure work they do on their property that meets a couple of the requirements. And one of the big ones here is that if you do the work yourself, and if you're a weekend warrior doing it on, at home all by yourself, we will actually pay you 110% of the money that you invest in your green infrastructure. I think that is a great deal, and it's a nice way to show how much we appreciate the work our residents do. And
great deal.
Great deal. And if if you are doing that yourself, your full rain garden should be paid for. Now, $1,000 will likely not cover a contractor coming in and doing all of that work, but you can get essentially a $1,000 rebate provided you have enough impervious area draining to that rain garden.
Sure. And that program, we have information on the website, but there's certain criteria you have to follow, and you can go and read up on that on the website as well.
And I will say our residents in the pilot area have been enthusiastic about this and asking lots of great questions, and we're working to fine-tune the policy just a bit so that we can have it clear for everyone exactly how much money they will be getting back.
Yeah, I think that's expected, especially when something is new. So the feedback from the public is essential too. Okay, one of the options, so in this pilot project, there's different levels of rain gardens people can kind of go through. We're also working through some permeable pavement. So people ask about this. I get a lot of media requests. What is this? Why should I care about permeable pavement? It sounds like it's really cool. And we kind of talked about what it is, but how does it work when it comes to snow plowing, or do you have to vacuum it out because it has holes in it, right? So talk me through how this is actually going to work in this pilot project and where it will be located, if people are curious.
Yeah, so in the pilot project on the street reconstruction, we've put in 3 different types of permeable surface. The first one is concrete that was made in a factory. So in a big warehouse, they pour the concrete out, and then it kind of clicks together, for lack of a better term, like Legos or something like this on the street.
Yep.
And it looks a little bit like Rice Krispie treats, but it's strong like concrete. And it is just in the place on the street where cars park. So as water flows off the street, it goes into this concrete and soaks into the ground where there's a big rock crib, and we're digging down to the sand layer that exists out there. So that water is going to go down into the groundwater. If it overwhelms the sand layer and the rock crib, there's a pipe that drains it into the storm sewer system. Just downstream of this is on St. Clair and Euclid Street. There's going to be a different surface on the top, right? So we're going to use paved drain as the product, and it's articulated concrete block. So this is a 1 foot by 1 foot block, and it has a little gap around the edges. So while the water doesn't flow through the block, it flows kind of through the cracks of the block.
Sure.
And same way as the pervious concrete where it gets into the rock crib and soaks away. And then the third one is something that we poached from the city of Milwaukee. And we put 4 of these precast concrete panels across the driveway.
The end of the driveway?
Yep. So as your driveway flows onto the street, it has to cross over the sidewalk and then go through that little apron that you drive off the street to get into your driveway on. And the goal here is to intercept water that comes down the driveway and down the sidewalk, capture it, and then route it to a rock crib so it can soak into the ground. So those are our 3 permeable surfaces on this project, and they do require maintenance. We have a street sweeper that will come out and vacuum those. And then we have the sidewalks. Some of your neighbors might look at you a little silly if you get the shop vac out and go vacuum your concrete sidewalk.
Yeah.
I'm not one of them.
Yeah.
And I have checked with friends, and some people do this even if it's not permeable because they're very clean and neat. I think there may be an option for us to have a walk-behind vacuum also.
Sure.
But that's something that you need to do to try to remove some of the accumulated sediment from in those pores so that you don't essentially create an impervious surface because it just fills in. So over time, if you're vacuuming that stuff out, then the water can soak in and infiltrate better into that concrete.
Water can't get through if it's clogged.
Correct.
Yep.
And that's something that in these areas, we make sure that they aren't on salt routes. So we aren't putting salt directly into the groundwater. That's something that we take into consideration with the design. And a lot of people don't realize that streets are designed to actually flow to a certain part. So Phil was saying that, we have the pervious concrete in the parking lane, and that street's then designed for the water to flow off of the pervious surface from the impervious surface to the pervious surface.
Okay.
So streets are designed to kind of move water in a certain way, and then we create that area where the water can soak in at that point.
So much cool stuff, you guys. We're wrapping up now because we want to hit on the resources and also one last question. So quickly, what are some resources for residents or anyone who's listening to this and they want to learn more?
So the Green Infrastructure Study website is cityofmadison.com/GI-study. And there's tons of links to the City of Madison's Rain Garden page. There's links to the EPA Green Infrastructure page. There's information about the street reconstruction project.
All of it.
All of it. On the City of Madison stormwater page on the engineering website, there's tons of information about the different studies that we've done and rain gardens and how to build a rain garden under $100, 1,000 rain garden program.
It's all there.
That's all linked there. Yeah.
And then there's additional resources on the Ripple Effects website, and that is kind of our coalition of communities in Dane County that are all working together towards water quality goals. And there's the Plant Dane program where you can buy inexpensive native plants once a year, some additional resources on how to build rain gardens and how all this stormwater management stuff works. And also a cool thing on our storm drain murals, which you may see around, and you can take a virtual tour of all those. So lots of fun stuff.
Last question. Why are we doing this? Why should other cities do this? Why use more green infrastructure options? Why does this matter as we wrap up? Last question to both of you.
For me, if you look at the way we've managed stormwater for the last 100 years, right? It's move it away as quickly as possible. And then we decided to move it away fast, and then also to try to slow it down and get some of the sediment out. And this is kind of the next step, right? Let's manage it where it falls on yards, add habitat, and reduce the overall volume so we have less of a risk of the lake flooding that we had in 2018. We have less opportunities for intersections and our streets to flood. It slows the water down, and it also recharges our groundwater and our springs, which are helpful for our lakes. So it's kind of the triple win.
Yeah, on top of it, there's been lots of studies about the social and neighborhood impacts of just having more native planting and green infrastructure throughout a neighborhood. So there's definitely not just the engineering stormwater solution, but it extends into benefiting the community overall.
Benefits all around. Thank you so much for being here, both of you, and sharing your insight. Green infrastructure explained in 20 minutes. That was pretty good, you guys. Thank you again for being here. Anyone listening, if you have more questions about this topic or anything else you'd like us to chat about, click over to City of Madison Engineering Facebook page because we are always here for you as a resource every day in engineering.